Hello students, welcome to this video, lecture number 15. In this lecture we are going to discuss the shapes of the orbitals. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. The shapes of the orbital is basically been influenced by the probability density functions of the electrons. That we know that electron cannot be found out with a 100% certainty. There is always a probability term will be there. Now, what is that we can write is very important things when we are going to determine the shapes of the orbital. That means the shapes. Now, shapes of the orbital means that is depends on the probability density of the electron. Probability density of the electron, that is depends on the wave function. So probability density depends on the wave function. Probability density depend on wave function as suggested by Max Born, that the probability density is basically the phi square at any point. What is wave function phi? Wave function phi, that we know that it has no physical significance, but it is a mathematical function and its function depends on the coordinates of the electrons in the atom. So when we are going to explore the shape of the orbitals, we have to take care of this probability density of this electron. And naturally, the probability density of the electron of every orbital is different. And when we are talking about the shapes, it is basically a diagram. When we are talking about any shape of anything, any macroscopic object, that what is there, the mental picture comes to our mind that its shape is like this. Means there is a concrete boundary of this object, and in the same fashion the probability that shape of the orbital also having these things, but it probability of finding is not 100% because there is a 90 to 95% probability, 5% is not there. So the shape of the orbital basically a surface boundary diagram of that electrons probability, and this is depend on the probability density. So we can say the shape of the orbital is basically the surface boundary diagram. So we can write this. The shape of the orbital is basically the surface boundary diagram. And what is surface boundary diagram? Surface boundary diagram is a three-dimensional diagram that has been drawn in the space, which is basically concerned with the constant probability density of the electron. That is a constant phi square, and it encloses a area where there is a probability of finding the electron is maximum, that is 90 to 95%. So we can say that shape is basically the surface boundary diagram which encloses a space, a volume in the space of the atom, where you can see, where you can find the probability of finding the electron is 90 to 95%. And this surface boundary diagram is different for different orbitals. For s orbital you will find it is different, for p orbital you find the different, and like this way. And this shape we are going to discuss on the basis of the surface boundary diagram. So first we will understand the shape of the s orbital. The surface boundary diagram of the s orbital. We know s orbital present in the s subshell. Is present in s subshell. And s subshell is having the L equal to 0. So how many orientation of the electron in that subshell? There is only one orientation. Only one orientation, because the m value is only 1, that is 0. Because m is equal to 0. So if there is only one orientation, then it will have the shape of the sphere. Sphere, at the center of the sphere is the nucleus. So surface boundary diagram of the s orbital is a spherical structure. The shape of the s orbital is, we can write the shape of the s orbital. Orbital is a sphere because its surface boundary diagram is spherical. Center of the sphere is the nucleus. So we can see that this structure, this surface boundary diagram is spherically symmetric. If it is a spherically symmetric, then what we see? Now what we will understand that the probability of finding when it is a spherical, when it is a s orbital is spherical, then we can say it is symmetric in all directions. Symmetric in all directions. So probability of finding of an electron, probability of finding of any electron is equal. And if you see, if you want to draw the shape of the s orbital in the two-dimensional, it will looks like a circle. This is the nucleus, and here the probability of finding this electron is given by this. This is one s orbital. So shape of this s orbital is spherical, is sphere, and it is spherically symmetric in all directions. So the probability of finding the electrons will be equal in all directions. So this you can see this 1s and 2s, but as the principal quantum number is increased, the size of this orbital is going to increase. So we can write 1s having the lesser size than 2s, 2s having the lesser size than 3s, and like so. So this is the shape of the s orbital. Now, in the orbital, you can see there is a place where the probability for finding the electron is 0. This is called the nodes or nodal plane. That we will discuss after this, how this nodal plane we will able to calculate for a particular orbital. So this is the shape of the s orbital. It is a spherically symmetric structure and having the nucleus at the center. So its L is 1. So number of orientation will be that is 12 plus 1 means if we put the value of 1 it will be 3. So there is 3 orbitals present in this p subcell. And what about itself? Shape naturally is not like the s orbital. S orbital having the spherical shape, whereas this orbital, that is p orbital, will have different shape, and its surface boundary diagram is like this. This is the surface boundary diagram of the p orbital. And we know there is a 3 orientation. The shape of this p orbital, 3p orbital, is same, but their orientation is different. One oriented along the x-axis, another is oriented along the y-axis, and other orbital, 3 number orbital, oriented along the z-axis. Depending on the which axis, which direction, the probability of finding the electron is maximum. So this is a term of px, py and pz. Px means that probability of finding the electron will be maximum at the x direction. Py means the probability of finding the electron will be maximum in the y direction, and like this in the z. So you can see this orbital, the shape of the orbital is called the dumbbell shape. This is called the dumbbell shaped orbital, and you can see it is like a dumbbell. So here you can see one thing, that the probability of finding this electron at the nucleus is 0. It is at this place and this place, this place and this place, there will be the probability of finding the maximum. So this is called the lobes. These two sections is called the lobes, and they have been touching at the nucleus. And if you draw mental picture, you will be there, that if you draw a plane which is passing through this axis, that is passing through this nucleus, you find a plane that where there is no probability of finding the electron, it is called the nodal plane. This is called nodal plane, where there is a probability of finding. Nodal plane means probability is 0. Probability of finding the electron is 0. And this is the nodal plane, and either side of this plane you can see there is a lobes, and that constitute the p shape of the p orbital. So you can understand this is the shape of the p orbital, and its shape is same, its energy is same, only different is the orientation. One is oriented in the x direction, another is y direction, and another is the p direction. And similarly, just like the s orbital, you will find as the principal quantum number is increasing, what is the shape of the d orbital? D orbital, we know azimuthal quantum number is 2, and it will have the orientation 2 into 1 plus 1, that is 5. So there will be the 5 orbitals, and among them 4 orbitals having the similar shape, and another orbital that is different shape. What is the surface boundary diagram of this orbital? Let us understand. This is the surface boundary diagram of the 5d orbital. So you can see there is a difference, and these four shape of the orbital is called the clover leaf. Clover leaf. And this orbital name is donut. This is donut and this is clover leaf type. And you can see all the orbitals, that is with the this is dxy, dy, dxz, dyz and dx square y square, and this is the donut is different from all these four types. But you can see these orbitals having the same energy but shape is different for this donut orbital. So you can see the surface boundary diagram, all these 5 orbitals, that is d orbitals, and same way you can see the d orbital having 3d is greater than, less of the 3d is size of the 3d is less than 4d, then it is 5d. So maximum minimum quantum number is 4, and you know the maximum number can be n minus 1, minimum number 0 to n minus 1, then it will have the principal quantum number is this. So these are all the shapes of the d orbitals. We have also understand the shape of the p orbital and shape of the s orbitals. Now one important thing that we need to understand, that is the probability density function is not same in all the places of the orbitals. That we are going to understand. Where the probability density is 0, it is called the nodal plane. So this is basically a plot as against the distance from the nucleus of the wave functions for the 1s orbital, and this is for the 2s orbital, and this is the probability density functions phi square for this is 1s orbital and this is for the 2s orbital. You can see the difference. The plot against the center of from the distance from the center of the nucleus, that is r, you can see this plot, and for the 1s orbital it drops at the near the nucleus, the probability of finding the electron is maximum, and it sharply decreases as we go away from the nucleus. But here the tendency, see one point there will be the 0, finding of probability of the finding of 0, wave function is 0, and then again it starts on increasing. After that a small maxima, it again 0. So this plane is called the nodal plane. Nodes, this plane is nodes, or you can say the nodal plane. Okay, and this nodal plane, or this is two types of nodal planes there. One is spherical nodes, which is also called the radial nodes, and another is planar nodes or angular nodes. And now we understand how do we able to calculate this. For the spherical node, it is given by this formula A minus L minus 1. N is principal quantum number, L is azimuthal quantum number. So for 1s orbital, what will be the spherical node? That you can see n equal to 1, then L equal to 0, this 1 means 0. There is no spherical nodes in 1s orbital. For 2s orbital, you can see 2, 0 minus 1, that is 1. For 3s orbital, it is given by 3, 0, 1, 2. So for s orbital, you can see the nodes is increasing as the principal quantum number is increasing. Similarly, another thing, that is a planar node or angular nodes. Planar nodes or angular nodes is given by this formula, That is, it is basically the L of these orbitals. L means what? Na, azimuthal quantum number. For d orbital it is 2 and like this way. So we can write the planar nodes. Planar nodes is equal to L. How we can visualize these planar nodes? Let us understand. So this plane you can see that is passing through the nucleus, and here in this plane there is no probability of finding of these free electrons, and that is why it is called the planar nodes. And it is equal to, planar node is equal to L, means when L equal to 1, that is for the p-orbital, it will have the one planar nodes. For L equal to 2, for the d orbitals, it will be the 2 planar nodes. So this is how you can see the nodes. Nodes is basically the place, region, the plane, the point where you can see there is the no probability of finding the electron. There is no probability of finding the electron for this planar node. So this total number of nodes, if you want to calculate, total number of nodes is basically the planar nodes plus your radial nodes. Here radial nodes is like this. In these places you will find this is a radial nodes. This is a radial nodes. Here this is radial nodes, and this is planar nodes. This radial nodes and planar nodes, that is given by planar nodes is L, radial nodes L, n minus L minus 1, that you can get n minus 1. And what is this radial node? The radial node is like this for s orbital, you can easily able to understand. Radial nodes, in this place you can see, find that the probability of finding the electron is very is 0. This is the radial nodes. Radial nodes for 2s orbital. Because 1s orbital there is no radial nodes. Okay, that is all for today's lecture. In this lecture we have discussed totally about the shapes of the orbital and the nodes of the orbitals. So if you like this video, you can share with your friends. Hopefully I am very much confident that it must be benefited to your studies. Okay, thank you very much.